Hello, everybody, and thank you, Janos, for the introductions. To John for the invitation to speak at Chemaxon's virtual user group meeting event. I've always enjoyed attending your user group meetings and meeting the team at Chemaxon as well as colleagues from the industry. As we all know, we are in unprecedented times, but we as a community always strive to get together and understand how we can support and network about our professional work and talk about leveraging the potential of the common tools we use in our craft that brings us together. As mentioned, my name is Mel Manalo, and I'm currently at MyoKardia since its early startup stages. We were about 20 to 30 employees when I started. The company was founded to find a cure for genetic cardiovascular disease, and I've been managing research informatics data for the organization, supporting the small molecule research drug discovery workflow. This means data capture, analysis, reporting, including project program support in understanding our data for SAR and compound lead optimizations. And to describe this a bit, the research data at MyoKardia comes from various departments, scientists, collaborators, and CROs. This means that small molecule information that goes through the life cycle from inception, synthesis, and registration must be combined with structure, calculated properties, biochemical potency data, DMPK information, pharmacokinetics, and various assays to progress a compound from a hit to a lead candidate. Now that's a pretty small snippet and general overview of the drug discovery workflow, but for today, I'm happy to walk you through, go through the outline here. MyoKardia's typical workflow within medicinal chemistry in support of a project. The pain points why we've embarked into this project, as well as the project objectives and how we chose Instant JChem as the central repository for the concepts database. Also, we have to customize this application as well as integrate it with our internal informatics framework. And towards the end here, we'll kind of bring it home together and tell you what we have plans next. And I'll let go to the next slide and talk to you about the workflow. So yes, whenever a project from its inception, a team is formed. You got your biologists, your chemists, your pharmacologists, and everybody else in support of that project. Our medicinal chemists will look at this target to design the molecules. And every week, project lead optimization teams meet to review these compound ideas. The project teams then nominate and select compounds for synthesis, and then selected compounds are assigned external IDs for triage to CROs, or if they're going to be made in-house. The successful compounds are then come back to MyoKardia and then registered in ComPreg, and then it gets a corporate ID from there. And in the next slide, I'm going to describe how we got to this point. And really, like I said, since I started MyoKardia for over 6 years, this operation that I just described on the slide prior is really manual. And you can imagine that, like with a bunch of files that are coming from all over the place, it's hard to kind of collate the ideas. And as you see in my second bullet there, chemists would often propose ideas that, have probably already been presented because chemists move from one project to the next, depending on where, the business takes them, right? And when chemists are in the same room together, it was kind of difficult presenting each individual ideas. Everybody has their own ChemDraw files or Marvin files or PowerPoints. And these files are dropped into our box repository, but is not chemically friendly to search. So in the end here, it was really difficult for the project team to capture the decisions on which compounds that are going to make it to the next step. And as mentioned earlier, and really the crux of it, and that's why, we've engaged Chemaxon to help us out, is that, these external CRO IDs are generated manually. And I think from here onto the next slide, Kevin will take over and describe to you the thought process on how we got from being doing a manual workflow and into now it's a automated workflow where all the concepts are going into the same location.
Okay, thank you, Mel. So my name is Kevin Sayo. I'd first like to thank ChemAxon for giving Mel and I the opportunity to speak with you today. So I am a research informatics specialist at MyoKardia along with Mel. I don't typically jump at the chances to present in front of groups of people, especially at UGMs, but I made an exception this time around because it is virtual, so it's a little more comfortable. I'm still hoping to meet a lot of you guys at future ChemAxon UGMs, but this is my very first UGM talk. So about me, I'm based out of the San Francisco Bay Area, and I've been fortunate enough to work with MyoKardia since 2018, and I mainly focus on expanding the informatics platform as we very rapidly expand. So no longer are we startup sized, we have huge ambitions to become quite a big company. So I want to share our story about how we implemented ChemAxon Instant JChem as the core database behind idea generation and management here at MyoKardia. Okay, so what were we trying to accomplish by doing so? As Mel mentioned, it got a little unwieldy having to manage, literally hundreds and thousands of ideas being generated by our medicinal chemistry team. So as the throughput of the MedChem team really grew, it was clear we had to invest in creation of a real database, not just, collecting ChemDraw and Marvin files and storing those on a file share. So for each of these concepts, we wanted the ability to not only capture just the structure, but also add metadata. So, tracking who thought up this idea, the date that it was thought up, ensure data integrity. So we wanted database security. We wanted an audit trail. We wanted to be able to standardize our concepts, our ideas, that is. We wanted a smarter way of reviewing these concepts in a group setting. So as Mel alluded to, we were doing this by, displaying up to 4 or 5 ChemDraw documents at once. So obviously, with everything in a database, was there a smarter way of doing this? We wanted to be able to track the group decisions to progress concepts to synthesis. We wanted to be able to triage and create external IDs. We wanted to be able to review all of this information after the fact. We wanted to integrate it with our current research informatics architecture. And most importantly, we really wanted something we can implement quickly. And a huge driving force there was as we expanded, we decided to open up our partnerships with additional CROs, and we needed a good way of automatically generating external IDs and tracking that. And of course, a database would be perfect for that. So project planning and implementation. So how did we actually accomplish this? So we already knew IJC existed as what ChemAxon markets as a database-centric management tool. And having already had some exposure to ChemAxon because we are fans of the JChem cartridge and engine already, having worked with the ChemAxon team and also having deployed ChemAxon ComparEdge here a few years back. So, we were pretty comfortable taking a stab at building our hypothetical system on top of Instant JChem. I also knew that it was built on NetBeans, which told me that it would be very development friendly. So I built an early proof of concept using the out-of-box Instant JChem tools and widgets. So end users tested this proof of concept and saw huge potential to consolidate and manage these concepts. It wasn't perfect. I got to about 80% of exactly what we wanted using just Groovy scripting and button scripts. I couldn't figure out some of the technologies such as Spring Framework, script hooks, Active Directory authentication. Now, don't get me wrong, ChemAxon documentation is very good. It's just given the timeline, it's just something I wasn't comfortable doing with. I'm not too good of a developer, so that's more of a knock on me than ChemAxon. So Mel and I reached out to John Usel and Tim Parrott, and they referred us over to the ChemAxon Europe guys in December 2019, shortly before we went on our holiday. Got back, so John Usel, Tim Parrott referred us to Norbert and Lucas Dopen, and they felt very comfortable that they can help us realize that dream. So We got back from Christmas holiday, and we actually kicked the project off in mid-January, having completed a scope of work. Lucas was very good at working with us. We built another proof of concept in our development environment, and we actually implemented the entire system into production by mid-February. All right, so how exactly does Instant JChem fit in our drug discovery process? So this is a concept, this is a process map that I created for the chemists to illustrate how Instant JChem would truly sit in the middle of the existing product, in the existing process. So a chemist with concepts fresh in mind throughout a work week would enter a structure directly in Instant JChem or import them as an STF. So a use case there is perhaps they're using ChemDraw, and they do a lot of copying and pasting, 20 structures at a time. They import these into Instant JChem, and there's sort of a feedback loop within Instant JChem to tell them whether an idea was already conceived in the past. And this goes back to what Mel was saying. Oftentimes, a chemist might think up a new structure, and that maybe that was proposed a year ago. And in our old workflow, you wouldn't really get this feedback loop. You'd have to reference possibly a document and a file share that was uploaded 8 months ago. It just was not clean. So once these ideas are collected, so these project teams reconvene on a weekly basis to review maybe the last, potentially hundreds of concepts thought up that week since the prior meeting. They'll review them one by one. If everybody likes the idea and there's group consensus to proceed with sending the idea for synthesis, then we'll triage these by creating external IDs. So for example, you might have 4 CRO IDs with 4 unique ways of identifying these structures you send to them. You can also add metadata directly into the database. So the priority, for example, the amount desired, you can add comments to the CRO, things like that. You can report off this information after the fact and then export it for sending to the CRO. And this is all based around IJC. So we had this existing workflow, just we didn't really have a solution to track every step of the process, and Instant JChem just seemed to work perfectly for us. Okay, so what does it actually look like? So this is basically what we call the concepts database. This is the main window that chemists look at on a day-to-day basis to manage their ideas. And so pretty much 90% of this is out of the box Instant JChem features. I believe they call them widgets. And this is an 8-structure molecule widget. Let's see, what else do we have here? Okay, so each concept is referred to by concept ID. So whereas in the past, you wouldn't really have a way of referencing structures, especially if you have thousands of them, concepts are now referred to by concept ID, which is a much more intuitive way of referring to ideas. Let's see, metadata here on the right. So we have automated timestamping, project, scientist, priority. These green bars here in the middle are visual cues for what the team had made for decisions and also triage. So for example, this concept here, number 8800, was decided upon for synthesis at CRO number 2 and number 3, and also for in-house with internal ID IHMYK00023. It's custom views here on the left. I mean, if you're an end user, you can clone off the project view. For example, if you wanted to see 16 structures instead of just 8. We have a button here on the bottom to control in-house built applications. This was using a Java pipe, and this was made possible because of IJC's inherent nature of being built on NetBeans. We have control for obsoleting compounds. So you wouldn't delete structures, you would obsolete them, and IJC would automatically hide them for you. And we have these decision buttons here at the bottom. These are what the chemists use to decide we like this idea, let's triage. Integrations, so Instant JChem is fully integrated with our web apps through Oracle database links. And then on the top right here, I have a little in-house built ChemDraw exporter and formatter that was made possible through NetBeans and Java pipes. All right, Mel, I'll hand it back to you.
Right. Thanks, Kevin. And so, yeah, so hopefully that was pretty helpful. In this short talk wherein we described how we were able to manage a manual workflow and automate this, and now we have a successful tool which got completed earlier this year, and it's widely accepted by the project teams, and it's used on a weekly basis. So it's really getting pretty good traction. The chemistry department recognizes that the system is an easy way to capture and manage new concepts in real time. And with that, it really not just saves the chemist time, but it saves the company time, and it makes the compound discovery process go a little bit faster. So the next step that we're thinking about this application is we need to track ideas conceived by multiple scientists. And as we mentioned, normally they would get together on a weekly basis, and if they a concept or an idea for a particular structure or compound gets proposed by everybody, then we need to be able to capture that. We want to be able to see if we can track the status of the concepts being synthesized at our CROs, and that would be a great plus. And also a full integration with Chemaxon's Compreg application, which we already have. And as Kevin noted in his diagram there, a lot of those are out of the box functionality, but it'd be nice to have that full integration with Compreg. And last bullet there is, and it's actually a project for us this year, is to determine the feasibility of integrating this with an electronic lab notebook. So I'm going to go in there, and just wanted to quickly thank our team members in MyoKardia Research Informatics and the chemistry department who tested the apps and adopted it, as well as MyoKardia management and the folks there at Chemaxon. So thank you again for this invitation to speak with you today.
Thank you.
Thanks.